Hello, biology. I hope you're well. Today we are going to be looking at the coronavirus vaccine. Now, I know this year we've had lots and lots of information and news about coronavirus. A lot of it has generally been quite negative, of course. It's affected many, many people. But I want to use this video as maybe a positive thing and how we're using science and specifically biology to beat the disease. So let's go. So we know this is what the coronavirus looks like, and we know that some of the symptoms of being affected can be things like a sore throat, cough, fever, diarrhea, loss of sense and smell, tiredness, and it can even lead to more serious complications like pneumonia and eventually death. We know that coronavirus is very contagious and it's affected many, many people, especially here in Mexico. So let's look at a little bit of the anatomy of the coronavirus. Viruses in general are quite simple structures, okay? So in the middle, this pink thing here, this is called RNA. It's kind of similar to DNA, okay? It contains genetic information, and this genetic information is what is making people so sick, okay? This is the dangerous part because this genetic code is making humans very ill. Now, around the this RNA, this genetic information, you have this red coat. Well, this is actually a fat coat, okay? Grasa, okay? So it's a coating of fat, and then embedded into this fat are glycoproteins, which are these yellow things sticking out, okay? So these yellow things, spike glycoprotein, this is what attaches to the cells, okay? So when coronavirus, if it does go into your body, down your nose, it attaches to these cells, okay? And then it inserts the DNA or the RNA into the cells. Final thing I want you to look at is this little blue thing, okay? So the scientific name is hemagglutinin esterase dimer, okay? But very simply, this is an antigen, okay? An antigen. And these antigens are on the surface of the coronavirus. I say that again, antigens are on the surface of the coronavirus. Very important. So I want to look at the immune system now. Now, the immune system is in your blood, okay? Now, in your blood, you've got different types of cells. You've got your red blood cells, which make your blood red, and it's your red blood cells which carry oxygen. You've also got platelets. Platelets are very important maybe when you hurt yourself, maybe you fall over and you have a cut, una herida, in your skin. What platelets do is they coagulate and they form a scab, una costra, to seal the wound and protect the body. The final part, which is the most important part today, are the white blood cells, okay? White blood cells are responsible for our immune system. They attack foreign bacteria or viruses. If we talk about bacteria or viruses from outside of the body, we call them pathogens, okay? So coronavirus is a pathogen because it is coming from outside of the body. Now, these white blood cells, we can divide them into two types, okay? So the correct name for white blood cells are lymphocytes, and these white blood cells can be separated into B cells and T cells, okay? So these are both white blood cells. I know they have different colors, but they are white blood cells, and they are B cells and T cells, okay? Now, B cells release antibodies, anticuerpos, which attach to antigens on the virus. Remember, the antigen is on the surface of the virus? Well, the antibody attaches to the virus and it acts as kind of like a sign. And the antibody is important because when the antibody attaches to the antigen, the T cells can activate. And the T cells attack viruses once they have antibodies attached. T cells need antibodies because they don't want to attack any cell in the body. If they attack healthy cells, then that can be very dangerous. They only want to attack cells which have antibodies because we know those cells, those viruses, are dangerous. Now, some people have weaker immune systems, okay? And these can be the elderly, those with obesity, and people with other comorbidities like diabetes, cancer, heart problems. There are others as well, but these seem to be the most common. And the main reason why that these people have weaker immune systems is their T cells are not as strong at attacking pathogens. Okay, if we compare these people to younger people have very, very strong T cells. But these people in these categories, their T cells are not as strong. Okay? So what we need is a vaccine. And I'm sure you've heard that many institutions around the world have been working on a vaccine for COVID-19. So how do vaccines work? So what we actually do is we take a weak or a dead form of the virus, okay? So that means we take the coronavirus, the virus, and we change its DNA. So remember the DNA or the RNA inside? We change it so it's no longer harmful. It doesn't give you a sore throat. It doesn't give you a fever. It doesn't affect your lungs, okay? It's a safe version of the virus, okay? But something very important is that this dead form of the virus still has antigens around the outside, okay? So we inject this weak or dead coronavirus into the body. Now, when it goes into your body, your immune system sees the virus and starts to make antibodies, okay? So the antibodies here can attach to the antigens. This is very safe because we know that the virus won't cause us any harm. So it's a very safe way to make antibodies. Finally, the antibodies fight off the germ, okay? So the body has plenty of antibodies. So if the coronavirus comes again, the antibodies are ready and they can attach to the antigens on the virus and the T cells can attack very, very quickly, okay? So that's how vaccines work. Weak form of the virus, so it cannot hurt you. Inject it into the body makes antibodies, they attach to the antigens, and that gives you immunity. We need to be patient. Vaccines usually take at least 2 years to be prepared. This vaccine that we're making for COVID-19 will be the fastest vaccine ever produced. Oxford University in the United Kingdom is in phase 3 of their vaccine trial. It will finish in November 2020, okay? Other organizations are also coming up with a vaccine. There's an institute in the United States called Moderna. They started phase 3 quite recently, but it's believed that Oxford University are the most advanced, okay? Now, Oxford University is doing the research. However, AstraZeneca, they are a pharmaceutical company, so they will produce the virus. They are already producing the vaccine. When the results show that it is safe, it will be ready very soon after. So we have to wait for November 20, and then we get the good results, hopefully, and then AstraZeneca can start making lots of vaccines, and then they can start sending them to people around the world. Now, maybe some of you have seen recently that Russia has actually have a vaccine ready, okay? However, there is something very important with the Russian vaccine. They have skipped phase 3, okay? Phase 3 is a phase of testing where you test it on many people, thousands of people, and you document the results to make sure there are no side effects, that there are no problems or dangers with the vaccine. Russia, and with their vaccine, did not do phase 3. They say that their vaccine is based on older vaccines which already passed phase 3 years ago. So they say we don't need to do phase 3 again. However, this is very risky. All vaccines are different because the RNA, like similar to the DNA, is different, okay? So what they are doing is something a little bit dangerous, okay? Maybe it will be fine, but we just don't know. What Mexico is doing is taking a safe approach. They have already ordered vaccines from AstraZeneca, and this vaccine will be safe and tested because they are doing the tests safely. So I just want to talk about some coronavirus vaccine myths, okay? Because as you come closer to the vaccine, maybe you'll hear some information, a lot of fake news, and it's important that we know what is correct, what is not correct. So, first one, the vaccine is dangerous. This is not true. The Oxford University virus, they have been following all of the protocols, all of the regulations when making a virus. So it will be safe when they have finished their trial, and when it's released, it will be safe to take. The vaccine makes us sick. Again, this is false. When you take a vaccine, maybe your immune system needs a few days to be accustomed because you're training your immune system to fight the virus in the future, okay? Maybe your body might feel slightly different, but it won't make you sick, okay? It's just your body adapting to the vaccine. It is completely normal. The vaccine will be expensive. Again, this is false. The World Health Organization have been working with Oxford University, and they're trying to set a limit of $3 per vaccine. In Mexico, they have already announced that the vaccine will be free for everybody. Many countries will get the vaccine before Mexico. False. Mexico is in a committee with 167 countries where they will all share the vaccine at the same time. Mexico has already ordered doses of the vaccine from AstraZeneca. So as soon as the vaccine is available for other countries, it will also be available in Mexico. It will take time for everyone to get the vaccine. This is true. You have to understand that on Earth, we are 7 billion people. In Mexico, we are 130 million people. So we are producing hundreds and thousands of doses of the vaccine. We're producing it as fast as we can, but it will take time. The important thing to consider is, who do we give the vaccine to first? We need to make sure that the people who really need the vaccine get it first. So people with the weaker immune systems that we spoke about before. Finally, one vaccine is not enough. This may be true. It's thought that natural immunity to coronavirus lasts about 3 months. So that means if you get coronavirus and you survive, maybe you have a natural protection, but only for 3 months. This is a short time. At the moment, Oxford University think that their vaccine should give protection for at least 2 years. This means that maybe in the future, after 2 years, we might need to take another vaccine. At the moment, we don't know, but it is a possibility that we will take one vaccine soon, and then in a few years, we'll take another vaccine. So this concludes our class today on the coronavirus vaccine. These are the questions that I would like you to do today. You can do them in the Google Docs, and then you can submit them onto Google Classroom. Okay? I will be here for the rest of the hour to answer any of your questions. Okay? And I hope I will see you again. And I hope you've enjoyed the video. See you in next class. Bye-bye.